go ahead and get started. Recording is started. Today is Monday, October the 11th. We are on day 1 of ellipses. Don't forget, we had day 3 of circles last Friday afternoon. So if you haven't watched that yet, you can watch it later today. You can watch it tomorrow, or you can watch it on Wednesday. It doesn't really matter. Also today at 12:30, I'll be having day 2 of ellipses, since I will not be here tomorrow or on Wednesday. All right, all of you should have time to finish up the bell work. If you didn't see the lesson from Friday afternoon, you probably wouldn't know how to do this. So I'm just going to show the answer. Center is 16, 13, radius is 2, and then there is the equation. I'm going to skip the work for now. You'll have to go back and watch the lesson or learn how to do day 3 from the modules. All right, let's get into today's lesson. Standard form of ellipses. We have a lot of notes to take. You have your paper, pencil, and Desmos open, or GeoGebra. I like Desmos better. A definition of ellipse is the set of all points in a plane such that the sum of the distances from two fixed points, called the foci, to any point on the ellipse is a constant. So I'm not going to go into depth of exactly what that means. Feel free to read the modules for the nitty-gritty on exactly what it means by the sum of the distances of two fixed points, the foci points. This diagram right here just shows how an ellipse is derived from taking a slice at an angle. And then here is a picture of an ellipse. Okay. The center is capital C. So the center is capital C. We will be dealing with variables lowercase a, lowercase b, and lowercase c. So capital C and lowercase c have different meanings when talking about an ellipse. Also note here, the Learn module has things mislabeled. So keep note of that. In mine, I fixed it. But we have the center of the ellipse is C. We have vertices A, B, E, and D. And then you have your two focal points, your foci, F sub 1 and F sub 2. We also talk about the major axis and the minor axis. So the major axis is just the longer segment. So this is squished, so it's longer in the x direction. So your major axis is, well, is parallel to the x-axis. So this right here going horizontally is your major axis, well, because it's longer. And then going vertically, this is your minor axis. So from A to B is the major axis length. From your center C to B, or your center C to A, that is called your semi-major axis length, because, well, it's half. So from C to B, that is your semi-major axis length. And then from C, your center C to E, or your center C to D, well, that is your semi-minor axis length. Kind of makes sense, right? Half of the entire length, so it's the semi-minor axis length, because it's, well, it's the smaller length out of the two. All right, more diagrams and equations. So we have two equations, one for when your ellipse is horizontal, like this one. This is stretched out in the horizontal direction, so this is that equation. And then you have an equation, which I don't have a diagram for on this page, that if your ellipse was stretched out vertically, if it was longer in the y direction, this would be the vertical equation. What is the difference between these two equations that you see? Yeah, the denominators are switched. Yeah, A and B. Yeah, the only difference between the horizontal and vertical is the location AB versus BA. Take note that, for example, this horizontal equation, which is this diagram right here, is an example. It is longer in the x direction. So in under the x stuff, you have the A. So this is telling you um, the A value will always be larger than the B value. Your major axis length is always going to be the A variable. And like it says here, if A is half of the length, so from your center C to one of your vertices, if this is A, 2 times A is going to be the entire length. So 2A is from vertex to vertex on the major axis. And then in the minor axis, 2B is from vertex to vertex. That's important to know. So A, major axis, B, minor axis. Also, kind of like you could think of A and B as kind of like the radius of an ellipse. Your A value, just like circles, when we had R squared, well, we have A squared. A squared is kind of like the radius. In this case, A is the longer one, right? So from the center to the vertex, that's like the radius in the x direction, and B is sort of like the radius in the y direction. Also, if you notice, I have little b, I have a little c here, and I have a little a. So again, the center is capital C. The distance from the center to one of your focal points is lowercase c. Take note of that. These are different variables. So from the center to a major vertex, that is your A distance. From the center to a minor vertex, that is your B value, your B distance. And then from the center to a focal point, that is your little c distance. All right, is everyone good on those variables and knowing the difference between A, B, C, capital C, lowercase c? A lot of background information, right? And just like radius is, remember it's r squared, so the number that you'll see underneath under the bottom here, the denominator, won't always be in the form of a value squared. You're going to have to probably convert it, just like we did circles. All right. All right, more pictures, more words until we're almost there, and then we can actually get to an example. All right, just like before, A is the major axis length. All right, so I'm sorry, A is half of the major axis length. So from the center to a major vertex, where they go right or left, and again, I don't have it labeled here. I'm going to draw it in just so we can see that. So from here to here, that is a distance of A. Now, if you notice, I created a right triangle. Right? And we have labeled, so from our minor axis, this is your distance of B, because B is half of the entire distance. Lowercase c, this is the distance from your center to one of your focal points. So I have this labeled as C. Also, a definition is the distance from your focal point to a minor axis vertice. That distance is distance A, which is the same distance as the center to a major vertice. So again, center to a major vertice, length A. Length A is also the distance from a focal point to a minor axis vertice. That is important to remember. And because of that, we can use the Pythagorean theorem. Remember how we can have a squared plus b squared equals c squared? But don't confuse the Pythagorean theorem, a squared plus b squared equals c squared, to this. These are not the same variables as an ellipses labeled a, b, and c. They are different. We all know from geometry that it's the two legs, a squared plus b squared equals the hypotenuse squared. So a squared plus b squared equals c squared. And that's why I wrote it out like this. So in Pythagorean theorem, we have the side A, which is actually our labeled C, which is the focal distance. So we have focal distance squared plus your semi-minor length squared is equal to the hypotenuse squared, which is our semi-major axis length, A. So we are replace the names just to show it's c squared plus b squared equals a squared. And then I solve for c. So if you know what a and b are, we can solve for the distance c. Pretty easy. Or if we knew, basically if we knew any two, a or b, or c or b, or c or a, or b or c, we could find the third missing side. So just write this formula down. Make sure you know what each one is. We have the focal distance squared plus the semi-minor axis length squared equals the semi-major axis length squared. You don't necessarily need this diagram if you just have this written down. But focal distance is C, semi-minor is B, and semi-major length is A. Okay, hopefully that is clear. I'd hate for you to confuse these variables, A, B, and C, to that of the Pythagorean theorem, A, B, and C, because they're different. But we are using the Pythagorean theorem. All right. We're almost to the actual examples, everyone. All right, just to cover. So writing an equation. So the information that we need to write an equation is, well, we need to know the center. We need to know the A value and the B value, A being the half the major axis length and B being half of the minor axis length. If we have these three things, we can write the equation of our ellipse. We also need to know which direction the ellipse is orientated, whether is it horizontal or is it vertical, and that really determines on where A and B go. If it's horizontal, so if it's longer in the X direction, the A will go under the X stuff. If it was longer in the Y direction, it would be vertical, and that means the A would go under the Y stuff. So let's take a look. Now we're to the examples. We got 4 examples today. All right, our first one. So I'm going to go ahead and write this one down. We're going to figure out what the center is. We're going to figure out what the A value is, what the B value is, and what the C value is. Once you know those things, we can figure out what the vertices and the focal points are going to be. All right, let's run through this one together. All right, so same problem. I just put the original problem right here. What is our center? What's our center coordinate? H comma K. -2, 0. Yeah, that is correct. -2, 0. And this is the same thing as a circle, right? Nothing different. Yeah, this is -2, 0. Okay. What is the A value? Anybody else? Same thing. Yep. The A value is 8. Yep. What is the B value? B value is 4. Yes. And I like to rewrite the equation just so I can see it. Remember, these are kind of like radiuses, right? This is the radius in the y direction. This is sort of like the radius in the x direction. So it's going to be the square root of those two numbers. So we got 8 squared and we have 4 squared. So I also, once you have the equation written down, I do like to put down A and B below it just so I can see it, even though we know that A is always going to be the bigger number, right? A is always bigger than B because A is the major axis, B is the minor axis. All right. Now for the vertices. All right. So what I also like to do is on the paper that I'm working on is I like to draw an ellipse to kind of show what's being depicted in our formula. Now we know that the A is under the Y stuff. So is our ellipse going to be longer horizontally or longer vertically? Yeah, it's going to be longer vertically. So I like to do an ellipse, just showing that it's going to be a vertical ellipse if we were to graph it. And then what I like to do is let's jump to the vertices. So from the center, remember the A is the major axis. So the A, we are going up and down. How many from the center? So from the center, we're going up and down 8. Yes. So we are changing the Y value. So from the center, which is we now know is -2 comma 0, we're going to go up and down 8 units in the Y direction. So we're adding, subtracting 8 from that 0. So 0 plus 8 and 0 minus 8. And this gives us these two coordinates right here. So now this is -2 comma 8, and this coordinate down here is -2 comma -8. So those are the two vertices for the semi, sorry, for the major axis. Those are those vertices. So far, so good, everyone? All right, I got somebody stepped away. That's not good. Stepping away, you're going to be lost when you come back. Thanks. All right, now for the semi-minor. So remember, the minor is the shorter. So we're going to be going left and right. From the center, we go left and right 4 units because 4 is half of the distance. So in the x direction, we are going +4 and -4. So again, in the x direction, we're going left 4 and right 4. That's why I have 4 and -4. And we're going in the x direction. So -2 plus 4 and -2 minus 4. So we get those coordinates. So this coordinate here would be -6 comma 0. This coordinate over here, this vertex is 2 comma 0. Right, then we're going to jump into the focal points. So we need to calculate what C is. We already know A is 8 and B is 4. So using this formula we're given the previous pages, we're just going to plug in 8 for A and B for 4 to solve C. So I went ahead and in this formula, I went ahead and just solved for C before plugging stuff in. It's up to you if you want to do that. I think this is easier just to plug it into here because you'll be doing those steps anyway, right? So we plug in 8, we plug in 4, we do the math, we get 48, and the square root of 48 is what? Four radical 3. Yep. 4 radical 3. So that's your C value. Okay, so then from the center, which is -2, 0, I will be adding and subtracting 4 radical 3. Now, am I going to add, subtract 4 radical 3 to my x or my y coordinate part? So we're kind of split in the middle right now. X, Y, X. Yeah, so Enzo says, isn't it on the longer axis? And he is correct. I don't know if I stated that or if it's stated that in words on the previous few pages, but your focal points will always be on the major axis. Yeah, I don't think I stated that. So again, your focal points will always be on the major axis. So based on, and this is another reason why I like drawing a little, just a little sketch to show that it's a vertical ellipse, is because we can see that it's in the y direction. So I'm going to also, on that little sketch, I'm going to put two little points. I'm going to put a point right here, and I'm going to put a point right here. And this is going to represent my two focal points. And I guess I can just do a center point too, right? So this helps me just keep track of whether I'm going up, down, left, or right. And because it's a vertical ellipse from your center, you are going up and down C. Remember, the distance from your center to a focal point is your variable C, your lowercase c. So we're going plus 4 rad 3 and down 4 rad 3. So we are adding it in the y direction, subtracting the y direction. All right. All right, so what is the first coordinate on the, we'll do this one. So what is the coordinate that we should have for our first focal point? Enzo says -2, 4 rad 3. Yeah, that is correct. Yeah, 0 plus anything is itself. 0 minus something, well, is itself, right? So there's your two focal points. All right, we have everything. And then these two bonus questions. What is the major axis length here? What is your major axis length? 16. Anybody else? 64? Question mark. So remember, the major axis length is from this vertex to this vertex. And then your minor axis length is from this vertex to this vertex. So 16, I think, seems more likely. Yeah, 16 is the distance. And then what is the minor axis length? Yep, it is 8. So remember, the major axis length This is 2 times A. So A is 8. So 2 times 8 is 16. And then your minor is 2 times B, and B is 4. So 2 times 4 is 8. Remember, A is half of the distance. B is half of the distance. All right. Um, it seems like there's a lot of stuff to do, but there really isn't. I just showed a lot of typing. And then on the next page, I use Desmos and I graph this. This is also a really good way to check your answer because when you type in the original problem, it's going to graph the ellipse for us. And then I went through and I typed in everything that we found. So on your TGA, you're going to have to do this. You're going to have to graph the ellipse. You're going to have to label everything and show me the points. So I didn't put the points on the graph. The points are in my list. So if I wanted to see your graph in your TGA and I saw, all right, here's the center. What's your coordinate? And I go over here. There's the center. So there's the coordinate of your center. That's easy. There's your focal point. There's your focal point. I can go and I can look. All right, there's your 2 focal points, and then there's the coordinate. Like, okay, you did it right. So on your TGA, you need to have everything labeled like this. Whether you do it by hand or use Desmos, I don't care. But if you just give me a Desmos of just the ellipse, so just this first line, you're not getting credit. You need to have the center plotted. You need to have your all 4 vertices plotted. You need to have both of your focal points plotted. And then you will need to have the actual coordinates written down, whether it's on your graph or on your paper. But everything should be labeled like this. How did I get it to do the markings? What do you mean? Or I turned on the label. Check. Here's the link to those to that graph to avoid typing everything in if you're curious. All right, let's go on. All right, next example. Let me give all of you 3 minutes to see what you can do on this. 3 minutes, ready to go. Right, it's about 3 minutes. So hopefully you got maybe half of it finished. So let's see what you have so far. Is this going to be a vertical or horizontal ellipse? Horizontal. And you know that because the number is bigger under the X stuff. So I like to do that. Yeah, I forgot to turn on my light. So whenever I switch between a light screen and a dark screen, it really affects my face. What is the center of this ellipse? 3,9. Yeah, 3,9. I agree. What is the A value? A value is 10. I agree. What's the B value? B value is 3. Yep. And let's go ahead and just rewrite it. And then let's go ahead and label the A underneath the X stuff and the B under the Y stuff, just so I can see it. It helps. It'll help us keep things straight of what's going on here. All right. Any of you have the vertices for the major axis? What are those two vertices? 319 and 3, -1. 319 and 3, -1. Yeah, those sound right. Ooh, they don't sound right. Dun, dun, dun. So nobody got it right. Yeah. Yeah, -7, 9 and 13, 9. So remember, it's longer horizontally. This is why I draw the picture here. So this tells us that the A value is left and right. So from the center, 3, 9, the major axis, you are going right and left 10 units from the center. You're going left and right. Remember, the A value is always the major axis. A is not X or Y. That's really dependent on which is bigger. That's why I wrote A here and B here. So A is the X direction, B is the Y direction. B is the minor, the smaller of the two. And then here's the work for it. So we are from the center, you are going to the right 10 and going to the left 10. And remember, left and right is the X direction. So 3 plus 10 and 3 minus 10. Okay. Okay, so with that said, what are the coordinates? What are the vertices for your minor axis? There we go. 3, 12 and 3, 6. Perfect. Right. We are all fast learners here, right? We learn from the mistakes. Yeah. So remember, in this case, our B value is Y because it's, well, shorter in the Y direction. So from the center, from 3, 9, you are going to add and subtract a distance of 3 units. So we get that. Okay. All right. And I saw Enzo already said the C value, but what's our C value? What did everyone get if you got there? Yeah, radical 91. And I believe 91 is prime. So square root of 91. Okay, now here's a question for us. Um, from the center, let's go ahead and show that. From the center, are we going to add and subtract radical 91 to the x or the y value? Correct. Yeah, the x value, because it's longer in the x direction. Our major axis is parallel to the x axis. So we are traveling from the center. You are traveling in the x direction to one of your focal points, and then from the center you're traveling left to the other focal point. So left and right is the x direction. So we are adding radical 91 and subtracting radical 91. Okay, so this first one on the left, what is that coordinate going to be? All right, Brady says 3 plus radical 91 comma 9. So is Isaiah, was it, so remember standard form, the term with the radical is always going to be last. So yes, you are all correct. So that is the coordinate of the focal point. And these are not like terms. You cannot add this radical 91 to this integer. These are not like terms. There you go. There you go. All right. So yeah, so there's the answers. There's all the parts. We found A, B, C. We found the vertices, and we found the focal points. Oh yeah, and then just for fun, what's the major axis length? 20. What's the minor axis length? 6. Yes. Very good. Very good. Right. Let's jump to the next one. Oh, and here's the graph. And if you want the link to that graph, there it is in chat. And let's jump to this one. All right. Let's do 4 minutes this time instead of 3. 4 minutes. Ready, go. Okay, time is up. Let's run through this real quick. What's the center? 10, comma 3. 10, comma 3. What is the A value? 11. What is the B value? 2. What is the C value? 3 radical 13. Okay. Right. How did everyone do so far on pulling out that stuff? Good. Good. The rest should be, I don't know, somewhat easy. Is this going to be a vertical or horizontal ellipse? It's going to be a vertical one. So let's go ahead and just draw a little picture of a vertical ellipse. We can rewrite the equation. It looks like that. What did all of you get for your vertices for the major axis? 10, 14, and 10, negative 8. Let me double check. Yes, I agree with those. My work for this looks kind of like this. So for the major axis vertices from the center, the 10 comma, 10 comma 3, 10 comma 3, we are adding and subtracting 11 in the y direction. That's why I have plus 11 and minus 11 on the y coordinate. So this is the work that I showed versus doing that grid. It's up to you how you want to show it on your paper. I'm trying to show you how to condense your work, but still have it make sense. And then the minor, what are the two minor points? 8 comma 3 and 12 comma 3. Yep, doesn't matter the order. Those look right. And same thing. So from your center, from your 10 comma 3, from the center, you are going left and right 2 units. So that's the x direction. So you're adding, subtracting 2 for the x coordinate, and that's how you get those. And then what are your two focal points? Interesting, interesting. Yeah, so I think the majority got it right. So remember, we're adding and subtracting 3 radical 13 for the y direction because it's longer in the y vertically. So we're going up and down 3 radical 3. And it's already simplified. You can't combine these terms together. So we have 3 minus 3 radical 13, and we have 3 plus 3 radical 13. You cannot combine these together. So the answer that you see is what you get. And I would say probably every single time that's going to be true. Whatever your C value is, it's probably going to have a radical in there. So whatever your integer is for your center, you're just going to tack it on at the end, plus or minus because unless your C value is an integer, there's going to be no way to combine these because they won't be like terms. Now, I guess it is possible your center could be a value that has radicals in it, and maybe you can combine them, but I'm going to say probably not most of the time. All right. Oh, and then here's the work for the focal point. What is the major axis length? 2. What's the minor axis length? 4. Okay, good. All right. Are these a lot easier than you thought they were going to be? I hope. Did you say yes? Yeah, a little easier. Yeah, with all the work that's on the screen, it does look more intimidating than it really is. As long as you can keep track of, as long as you understand what the A value represents, what the B value represents, how to calculate the C value, as long as you understand those and the parts, this is pretty easy to approach. If only I could. All right, we got one more example. Here's the graph for this one. And again, graphing these is a good way to check your answer because, once you type stuff into Desmos to graph it, if things don't line up properly, you can see it pretty clearly. There's a link for that Desmos, but yeah, you type this in. There's the original problem. It's going to graph that for us, and then once you type in everything else, if stuff doesn't land where it's supposed to, like the major vertices, if they're not actually on the graph, like they're either floating outside of it or inside of it, you either didn't type it in right or you didn't calculate it right. If your center doesn't look like it's the center, you probably didn't do it right. If your minor vertices are floating outside or inside the ellipse, you didn't do something right. The focal points are a little harder because really these focal points can kind of be, anywhere between the center and your major vertices. So as long as your focal points are on the major axis length and they're inside your ellipse, well, that's all you can really check. But that this focal point being so close to the vertices, it makes you question if it's right or not, which it is. Yeah, it's definitely a very tight squeeze. All right, our last example right here. Oh, looks like we are out of time. It is 11:31. So let's go ahead and stop here. I'm going to go ahead and just show the solution for this last one. Feel free to look away in horror before you actually do it, or just go ahead and glance at the answer and you can work on it later. But this is the answer for this last one. And this one is longer in the x direction. So it's a horizontal ellipse. All right, so there's that solution. And here is the graph for this one as well. People that are here, I am also going to link this presentation in chat. Give me a second. All right, so there's that. All right, everyone. Hopefully, I see some of you at 12:30 for day 2 of Ellipses. If not, you can watch the recording tomorrow or on Wednesday. All right, everyone. Have a good rest of the week. And as always, I hope we learned something.